אתם עומדים לשמוע את אחת השיחות המרתקות ביותר שהיו לי. האורח שלי היום הוא פרופסור קנת סטנלי, הוא היה אחד המדענים הגדולים ב-Open.AI, היום יש לו חברת סטארט-אפ משלו, וב-Open.AI הוא עבד על מה שנקרא Open-Endedness Questions, או בעיות פתוחות. אם אני שואל אותך בין כמה אתה, זה שאלה סגורה, אבל אם אני אומר מה אתה אומר על המצב, זה כבר שאלה פתוחה. איך Open.AI או איך ChatGPT מתעסק או מבין את הרעיון הזה של בעיות פתוחות, או אלגוריתמים של בעיות פתוחות. למעשה, לתוך כדי הסיפור הזה, הוא הגיע לחקור גדלות, אוקיי? את הרעיון הזה של רעיונות גדולים, והוא הגיע דרך עבודת הדוקטורט שלו שהתעסקה באלגוריתמים גנטיים. הוא פיתח איזושהי מערכת שיכולה לייצר תמונות באמצעות אלגוריתמים גנטיים, ונתן את זה לציבור, לשחק עם זה דרך אתר האינטרנט שלו. ומה שהוא ראה זה, שכאשר אנשים מייצרים כל מיני דברים יפים בתוך עולמות התוכן האלה, הרבה פעמים רגע לפני שהם מייצרים, הם לא יודעים שהם הולכים לייצר את זה. זאת אומרת, אתה לא יכול לתכנן יצירה גדולה. הספר שהוא כתב בעקבות הסיפור הזה נקרא Why Greatness Cannot Be Planned, The Myth of the Objective. כאשר יש לך מטרה בראש, הרבה פעמים אתה לא תשיג את הדברים הבאמת גדולים שנמצאים ממש מעבר לפינה. הרעיון הזה שבא לידי ביטוי באלגוריתמים הגנטיים, הוא בעצם רעיון פילוסופי הרבה יותר גדול, והספר הזה בעצם מספר את הסיפור או את ההשלכות היותר גדולות של הרעיון הזה. פרופסור קנת סטנלי הוא באמת אחד המדענים החשובים ביותר בתחום של ה-A.I היום, ובין היתר הוא מנסה להשתמש במודל הזה כדי להסביר למה אנחנו לא יכולים לצפות ש-GPT-5 יהיה מדהים בדיוק באותו אופן ש-GPT-4 יהיה מדהים. למה כאשר אנחנו מתכננים ומתכננים ומתכננים, אנחנו לא נותנים מקום לגדלות אמיתית לבוא ולהופיע. אז שווה לכם מאוד להקשיב לשיחה הזאת. שלום לכולם, לי קוראים רועי יוזביץ, ובערוץ הזה אני מדבר עם החוקרים הגדולים ביותר בעולם בכל מיני נושאים. אם השיחה הזאת מרתקת אתכם, אז קודם כל יש עוד המון שיחות של AI, אבל אתם גם מוזמנים להסתכל על שיחות אחרות, לראות מה אנחנו עושים, לקחת חלק בערוץ, להירשם ולהצטרף לטלגרם. הערוץ הזה והשיחה הזאת, כמו כל השיחות, היא במימון יוזביץ. אז אם אתם רוצים לעזור לנו, אתם יכולים לעשות את זה דרך חשבון הפטריון שלנו, דרך כפתור הסופר thank you, ואתם יכולים להיכנס לחנות ולהזמין ספרים, להזמין קורסים דיגיטליים, ואפילו להזמין אותי להרצאה על בינה מלאכותית בארגון שלכם. ועכשיו, פרופסור קן סטנלי. Ken Stanley, thank you so much for coming. How are you today?
Thank you for having me. Great to be here, and I'm doing very well.
Okay, we have so much to talk about, but I think that I would like to start with the news. Recently, OpenAI released the new text-to-video engine or model, which called Sora, and it blew the internet away. The results were impeccable, were amazing. So before I dive into the philosophy of what I would like to ask you, what do you think of this great leap of text to video?
Well, I was similarly blown away. I mean, I was surprised. I didn't think that we were quite ready with the compute and technology to see that kind of result. And so when I saw it, I was surprised. It makes me think that it either takes less compute to do that than I thought, or OpenAI has acquired a lot more compute than I thought, like one or the other. But it's quite impressive. I think it still shows that there's still room for improvement, despite that it's extremely impressive. There's still obvious flaws and errors that you can see if you look at these videos. For example, people have spoken about the chessboard that was 7x7. This is not the end of the world, but it just shows that there are still challenges that remain, and it's kind of an interesting research question what it takes to plug those holes, or what it actually indicates deeper down inside of the model that might be wrong. Is it something more superficial, or is it something more deep? And so there's certainly still research questions that are left to be answered. But overall, obviously, this is a major advance and exciting to see.
It's not the 6 fingers that we used to see with Midjourney, and even people, the lady in Tokyo, someone told me, listen, in this second, her leg flips, but basically in another level. And I read the research paper or the research articles that OpenAI produced, and they lean upon, you know, previous research, vision transformers, etc. But it seems that there is a genuine leap. One cannot see all the reference articles that they present that, you know, made the basis to what they did. They did something, I think, in my opinion, completely different. They created something new, something novel. And here I come to another aspect that I would like to ask you about novelty. So would you say that although they rely on various and past research in vision transformers, etc., what we have seen in Sora is almost completely new?
It is. I mean, it's qualitatively new. I mean, from the point of view of someone observing it, it feels very new. But we don't know what's underneath the hood or how new that is. It could just be pushing whatever previous technology existed to its limit. It could be that. So that's not really new. It's just that there was farther to go on that runway, and maybe there's still farther to go, but we don't know. I mean, they haven't divulged the underlying details. But certainly the experience is new, and that is significant because you can see how it opens up entirely new possibilities that are only just beginning to be imagined. I mean, in the last few days, that, you know, it's essentially like a dream generator. And it's hard to, like, the effect on our psychology of seeing video that's produced the way you would produce imagery is like really novel. I mean, that's because it was very hard to produce like a video, like before this kind of technology that fits some kind of artistic vision. I mean, you can't just sit there with a paintbrush and do it. And so it requires a lot of effort. And the ability to do that now just rapidly and sort of anything you can imagine that you can describe. I mean, it's hard to imagine all the new things it opens up. So it's a new playground, both for the audience and for the creator. And so I think it counts as something novel and a new stepping stone in the world.
You know, my daughter is a Blender artist, and there are some things that, you know, you can create using Blender, but the time and effort that it takes, you know, to model, like there is this disco kangaroo dance, and it's like Pixar. And I had Scott Aronson on the show recently, and we talked about AI safety, etc. And it seems, you know, I read the GPT-4 paper that the lion's share of what OpenAI does has to do with AI safety and all the things relate to AI safety. And it seems that with Sora, which is going to be much more important, you know, the idea of that I don't any prompt to be converted into video. I don't want porn. I don't want pornography. I don't want violence. I don't know. I don't want many things. And it seems that, you know, most of the CPU, or I don't know, at least 50% of the CPUs of the engineers at OpenAI goes in that direction. Now, my question is, would you agree that a lot of the brain of OpenAI scientists and researchers and engineers go to the AI safety? And would you say that maybe we also need to decrease the amount of safety?
Well, yeah, I would agree that a lot of brain power is directed towards safety. I don't know if it's 50%. I don't know the exact number, but I think OpenAI does care about safety and dedicates significant resources to it, and attacks it from multiple angles because safety doesn't really just mean one thing. Now, at the same time, you're saying, are we putting in too much safety? So yeah, that's a different question. And I think it makes sense that people would ask that question, you know, because you can feel frustrated interacting with these kinds of models when they refuse to answer questions or try to obfuscate on a question when you feel like it's a legitimate question and it's not anything bad and it refuses to answer for your own safety, and then it feels silly, and it feels like there's too much layering of the safety stuff. So in that sense, perhaps there's in that sense too much, but I think this is a very delicate balancing act. It's hard to really thread the needle, like the exact right balance, because as soon as we start to reduce the amount of constraint and let people explore further, have less safety, there'll be lots of complaints on the other side then of all the bad things that are coming out. And so it's sort of, you can't satisfy everybody either way. And they're probably trying to do their best, but it doesn't help to say that. You still have to acknowledge that it's frustrating to encounter the level of constraint that we encounter and the sort of guardrails on exploration. I would note, by the way, I played with these models before they went through their fine tuning, like what the raw models are like. They're certainly very interesting, like without the guardrails. I'm not recommending that those kinds of things would be necessarily available to the public. But I can recognize that some amount of, interestingness has been lost through the protections of safety. But it's a trade-off that we have to think about.
I want to give 3 examples, okay, that I would like you specifically to address. One, I had a talk with Isaac Cohen, which was one of the authors of Revolution AI in Medicine, GPT-4 and Beyond, okay? So he was one of the authors of this book. And what he said is, that non-restricted versions of Da Vinci 3.5, I think, I don't know, were much better as the medical doctors than the more restrictive version. So he said, I loved as a doctor, I think that they could communicate much better what they need to do. And he is one of the authors of the book Revolution AI in Medicine. The other example is the paper from Cambridge, I think, the GPT performance decrease over time from, I don't know, from the March to June, and they attribute this decrease in math problems and other aspects to basically, among other things, to safety. And the last thing, which was between the current war between Israel and Gaza, I asked GPT, including the web, and my thesis was that GPT was heavily trained to see the world through the lenses of politically correct. And what happened during October 7 was not politically correct. And if you're trained to see the world in a very politically correct nature, when reality will be non-politically correct, you will not have the ability to absorb, to understand reality. So those are the 3 examples that I have regarding, the extra safety that basically ruin the performance for the better. What do you think?
Mm-hmm. Well, I think actually this is a very complicated issue because, on the surface, it seems like this is an argument about how much safety to layer on top of these raw models, which are less safe, but arguably better in some ways. Like the author that you mentioned said it was better at being a doctor. That's his opinion. But I think that's actually not the actual fundamental issue that's actually instrumental here. But I would note that, I'm not sure it was really better. He says it's better. I take his word for it. He's a doctor and I'm not, so he knows more about it. But the thing is, the reason I'm not sure about it is because, those models are a model of a distribution. That's what they are. They're not actually individuals is the way, before they get fine-tuned, they're not individuals. They model the distribution of all human behavior. And so, that means that if you query the model once, you're getting a sample of humanity basically in that single query, like what one type of person might say or something like that. You query it again, you're getting a different sample. It's somebody else. On average, it'll be the average person. If you're asking about medical stuff, probably on average, it'll be the average person talking about medical stuff, which might be a doctor. But the thing is, when you're modeling a population rather than an individual, of course, sometimes you're going to get outliers sometimes. And sometimes most of the time you won't, but sometimes you will. And outliers tend to be weird. And so even if on average it tends to be really good, once in a while it'll be crazy. And that's like what a raw model will be. A raw model is capturing a distribution. And so I don't think that's necessarily what, overall better. It's just different. It's just a different kind of experience. We would really like to have something that's neither one. Like the raw model is not a good, it's not the kind of thing I would want to be making medical decisions because of this distribution aspect of it. I would want it to be consistent, like 99.99% of the time, always a reliable doctor. Not once in a while it just goes crazy. But I also don't want it to be this overly safe, like guardrail thing that's been basically lost all of its original sharpness and purpose. Like that's also bad. So it's like neither end is really ideal. And I think what it illustrates is that the problem that we're really grappling with is that our training methods are not as targetable as, if that's a word. They're not amenable to targeting to the degree that we'd really like, because what we'd really like is to be able to just tell it what it needs to change about its behavior without having side effects and unintended consequences that have absolutely nothing to do with what you're saying. Because like it goes through all the safety fine tuning. In theory, that should have nothing to do with its medical knowledge. It's like if I say like, don't, please, like show it, like never say anything that could be construed as racist. Well, what does that have to do with diagnosing diseases? Like it shouldn't have anything to do with it. But because we can't explicitly say things like that, that's not how training works. You don't explicitly tell it how to change. Yeah, sorry.
But since, this is what social engineering is all about. You can't just change one thing and this one thing change. Maybe social engineering is so complex that I change one thing and I have, things that I didn't expect. And those systems are so complex and so complicated, and they have trillions of neurons. Maybe if you change one thing, you will see changes in places that you never expected. For example, you say, don't be racist, and this somehow, we don't know how, change its ability to solve math problems.
Well, we don't. So you can, if you're in a chat with ChatGPT, you can literally say, "Don't be racist." But it's important to note that doesn't actually change the underlying model itself. That's just restricted within that conversation itself. And so, as soon as that conversation's over, all of that information is lost, and it's back
No,
to
I'm
its
talking
baseline.
about your training.
So
I'm talking about your training.
yeah,
I'm talking about the
understood. Yeah,
OpenAI training.
Yeah, right. Understood. So I just want to make that clear for the audience. We're talking about the actual training of the model. So the training of the model, just to be clear, because the training model is not like that. You don't say things like, don't be racist. That's not like a training. That's not a part of the training procedure. You have to show it examples. Like it learns through examples. It learns through examples in the pre-training. It learns through a different kind of example in reinforcement learning. But what that means is it's making inferences from implicit signals. Like you can't explicitly tell it something like don't be racist. You have to show it how not to be racist. And then it will infer what that means. Because it has to make inferences, there's a much more room for it to bleed into other aspects of its behavior. Because like if I just told a person don't be racist, it wouldn't cause them to be a worse medical doctor. I mean, a person can compartmentalize things easily within that, and then they could reorganize their particular way of modeling the world. A human wouldn't have as much of a struggle as one of these models. But the problem is we can't tell the model that explicitly. We can only show it implicit examples, and that just doesn't work as well. And so to me, what it highlights or surfaces about all of this stuff is that we ultimately would benefit from a much more sophisticated kind of training method where you can just be explicit. And then a lot of these things would no longer be stuff that we're talking about right now. It would get around these problems.
Okay, but we don't have this yet. Now, with your permission, we'd like to move on to another thing. In OpenAI, you led the open-endedness. How do you say it? I'm sorry.
Yes. Open-endedness.
open-endedness. I'm sorry. Never mind. And I think that this is a very important term with regards to your work. So in psychology, we have an open-ended question and we have a close-ended question. Huh? Would you like to go out with me on a date tonight? This is a close-ended question, and you can be either yes or no. But what do you think? About what? I don't know. It's an open-ended question. Therefore, it is much more interesting. And I think that the idea here is interesting. Open-ended question tend to be much more interesting, but they are vague. I can answer them in multiple ways, and some of the ways is not what I expected in the beginning at all. So could you please take my open-ended 101 in psychology and transfer it to your research?
Yeah, okay, so there is a connection. This is like the term open-endedness, which is a mouthful. It refers to something broader than just the psychological point that you made, but that is related, the idea that you can ask an open-ended question. So basically, when we say you ask an open-ended question, what we mean is you don't necessarily know where it's going to go. You wouldn't be able to predict where I'd take that. And that's part of the fun of it. It's like we're going on a ride and we're going to go on an adventure. And open-ended systems have that quality, but they're about more than just responses to questions. They're really about entire systems that are creative and exploratory in the sense that, let me give you a couple examples, actually, that'll help. So there are a couple of, let me start by saying this. So I've been interested in open-endedness my whole life because I've thought that open-endedness is like one of the most deep and fundamental aspects of human nature. Like I think humans tend to be very open-ended. And so I've been trying to understand open-ended systems and how it's possible for an intelligent system to be open-ended in order to understand things like human creativity. And in the study of open-endedness, there's two very canonical examples of open-ended systems that are inspiration for the field. And I just want to tell you what those two are, because it'll help to understand it. The first one is natural evolution. It's this idea of a system that starts with something like a single cell, and then from that single cell, you get the entire tree of life, all of the things in living nature, which include things like photosynthesis. It invented photosynthesis, the flight of birds. It invented flight. Human level intelligence is one of the inventions. And this is a very remarkable kind of a process because the longer you run it, the more interesting it gets. In a sense, like if you're a computer scientist, you can look at it as a single run of a single algorithm that invented everything in that single run. Usually in the field of machine learning or artificial intelligence, we think of when you run something that there's an objective for the system and then it hits the objective or converges to the objective, and then that's success. The open-ended systems don't have that property because there's no end. So natural evolution is remarkable because it continues forever. And so, it's not literally forever. It's only been somewhat more than 1 billion years, but that's pretty much close to forever as we're ever going to get. And what's amazing about it is still going after more than 1 billion years of running. And every generation is more interesting than the last in the sense that there's more things invented, more complexity in the system, and so forth and so on. And this is what we mean by open-endedness. We don't know where it's going. Humans are not the final destination. We're just one stop on this endless voyage. And so that's an open-ended system. And the other canonical open-ended system is civilization. Civilization, which similarly goes from things like wheels and fire when we start to now things like space stations and computers, and also includes like all of the arts and the humanities and politics and everything else that's been invented by humans as well. It's not just technology. And so that is also a system that gets more interesting and more complex the longer it runs. The inventions are built from previous generations, just like in evolution. Of course, there's big differences. Like it's not like your car has a baby. But we see inventions from the prior generation, and then we build new ideas off of those old ideas and so forth. And so civilization also has this open-ended aspect. And what's remarkable when you think about evolution and civilization is that they're like an open-ended sandwich with us in the middle. Because think about it. Human intelligence comes from evolution, but civilization comes from human intelligence. And so we're right in the middle of all that. And that is the thing that inspires artificial intelligence, our intelligence. And so it could be argued that to capture human intelligence, to actually get something at the human level, you've got to capture open-endedness, both in the sense that to get there, you might need open-endedness because evolution produces us, but also to really be like us, you have to be able to produce open-endedness to be an actual participant in civilization, which is fundamentally an open-ended process. And I just want to make one last point about it, which is that this is really the essence of our humanity, is our open-endedness. You know, if I give you two 5-digit numbers and you could multiply them in your head, that would be very impressive. But no one would say, oh, the humanity of it. It's not a really like a declaration of your humanity. It's just a technical algorithmic thing. When you say, oh, the humanity, you're thinking about the things that were created, like all this stuff when you look around, like look around your room and everything that's been invented, that's giving you this kind of modern standard of living and all of the things that you enjoy. That's where, oh, the humanity is. That's open-endedness. And so that's a really important part of who we are. And AI without that is arguably missing the fundamental essence.
Okay, so I need to go a little bit to philosophy. The idea of can I treat your interpretation of open-endedness systems as non-objective? The idea of open-ended is no, there is not an objective. So if I go to the materialistic view of evolution, I say, okay, there is no objective, but it seems that in civilizations, something is different. So we have some objectives. Maybe we don't pursue our objectives. Maybe civilization take its course, but it seems that you're absolutely correct that human beings create civilizations, but we create it with some objectives in our mind. So in my opinion, it's a little bit different, evolution and civilization. Would you agree?
I do understand the point.
With respect
Word
with respect to the idea of objective. I'm sorry.
Yes, yeah, understood. I mean, that word objective, and I actually do like the term non-objective. I would actually say that things like evolution are non-objective. I would say civilization is non-objective, but it's a slippery word. I want to acknowledge that. And you can get into semantic arguments. Semantic arguments aren't super interesting. So I try to avoid just being just a pure semantic argument. Like, let's get to the heart of the matter. Like, the heart of the matter is that what is that this when we talk about being non-objective, if I would say civilization is non-objective, what I mean is that the system in aggregate is non-objective. Individuals within the system might have objectives sometimes, or maybe even a lot of the time, but there's no aggregate objective for the entire system. And so, you might have an objective like you want to earn enough money to buy a house. That's your objective. That's not civilization's objective, though. So it's important that like these systems in aggregate don't have like a holistic objective. But also, I would point out with the word objective, some of the things that people informally call objectives, I think of as constraints. And so it's like if you want to, like, for example, survive. I don't think of that as an objective in the usual sense. Of course, informally speaking, it's fine to call it an objective. You can call it whatever you want. But like in a machine learning sense or something like that, I don't think of things like survive as objectives because they're not targets in a space of possibilities. Like an objective to me would be something like a refrigerator. Like you can make a refrigerator. Now we have one. You can't make survival. Survival is a constraint on everything you do. Like you can't do anything if you're not surviving. And so like in the search for various things, which you'll find, which are objective things, survive is one of the constraints you have to satisfy or you'll never find anything at all. And so often people kind of mix those two things up. Like from a machine learning point of view, I think it's an important distinction because I often think of this in terms of algorithms because I'm interested in making actual open-ended algorithms. Like in machine learning, usually you're pointing to place in a space of possibilities that you want the algorithm to go. That's like the typical objective function. So you can't just point it to survival and say, go survive, because it's not like a specific single thing. Like there's a million different ways to survive. And so it's not what I would formally think of as an objective, but I can see why this can get confusing. So it's just what I'm talking is a more kind of formal notion of objective. And also I'm talking about at the aggregate level, not the individual level, like the whole system not having an objective.
So I think that your distinction between the aggregate and the individual is crucial. But again, from what I understand, history doesn't have a trajectory line. So a trajectory line to history, like in the philosophy of Hegel, would consider as some course of an objective, okay? And we don't say that history has a trajectory line. And this leads me to the idea of genetic algorithms. So your PhD, in your PhD, you created the NEAT algorithm, which is basically a genetic algorithm, a very popular, very smart. And you... in one of your lectures, you said we can take an algorithm and let it run on a computer for 1,000 years and come back after 1,000 years and see remarkable things. Okay, basically, and you lament that we can't wait 1 million years or 1 billion years and come back after 1 billion years and okay, look what I have done. Now, with my humble experience with genetic algorithms, and I think about this over and over because I teach genetic algorithms, the idea is that genetic algorithms, what enables them to work in the context of machine learning and computer science is the idea that we know that someone from the future takes the current algorithm and pull it to the correct destination, because the loss function or the fit function, as we call it in genetic algorithm, basically say, okay, you're not where you should be because I know what you should be or where you should be at. And you can't explain genetic algorithms in the context of machine learning and computer science with local evolution, because you need some fit function from the future that will take you to the desired place, which leads me again to the idea, maybe this hand from the future basically is the objective thing.
Well, genetic algorithms in computer science, maybe unfortunately, they've led to some confusion, I think, in the interpretation of evolution, because the conventional genetic algorithm is not like evolution in the natural world. I mean, like you mentioned, the fitness function, which is a kind of objective or loss function, is usually pointing to a place that we're hoping that you'll arrive in the future, a certain kind of behavior, which has been described in the fitness function. That is not the way that evolution in nature works. There's not an objective that's been explicitly formalized for the system where selection is basically all according to the objective. If that was the case in the natural world, that would be called breeding. So it should be called genetic breeding, because this is a breeding algorithm. It's like, I want a faster horse, so I'll just select the faster children, and hopefully the next generation is faster than the previous. This is just breeding towards an objective. But actually, nature is not like that at all. There is no explicit objective. And so to get natural-like evolutionary processes would take a really radical departure from conventional genetic algorithms. But that does not mean that it's impossible. I mean, that's basically what I spent a big part of my career doing, was trying to understand how to formalize something that's closer to what's going on in nature in this like non-objective sense. Because what nature does that's particularly remarkable is its creativity. Like a lot of like textbook stuff you read about evolution talks about it as if it's objective, because it talks about local competitions that happen. It's like this gazelle running away from a lion or something like that, and everybody has to get faster in that arms race. But to me, those are like those are the easy questions. It's like it's easy to explain stuff like that, these kind of local objective types of increases or gradients. The thing that's really interesting to me is the overall, again, the aggregate system, which is massive creativity, which is divergence. The overarching characteristic of evolution is not this kind of optimization that happens locally. It's the divergent property that you get species after species after species, and they're all different and they're all incredible and all are like completely different kinds of inventions. Like, what does photosynthesis have to do with flight? But they're in the same system and the same algorithm. And so that's a completely different kind of algorithm. It's not what traditional genetic algorithms have addressed. But in recent years, we've made progress, I think, towards understanding these more open-ended kinds of, you could call them genetic or evolutionary algorithms.
Okay, so again, it's mind-blowing. And with your permission, let me go to move on to your book, which was published in 2015, Why Greatness Cannot Be Planned, The Myth of the Objective. Now, on the book cover, we have a butterfly, and the butterfly, I think, is very important in the context of the book, because we mention over and over the idea of butterfly being emerged out of non-objective search for butterfly, and I will let you explain the idea of how one can breed pictures, okay, together. But again, the idea of, let me go to the philosopher Karl Popper, who said, we can't anticipate new inventions, okay? This is basically the critic regarding historicism. The idea is that if you say, oh, one day I might invent the wheel, the wheel, what will be the wheel? The wheel will be like this. I just invented it. So you can't participate, or you can't, I don't know, ponder or think that one day you will invent something, because the minute you think about this something, it has been already invented. And this is a philosophy side. So if you can please just focus on, let's, with your permission, start with how one can breed two pictures and how and what butterflies has to do with your book.
Yes. And I would just preface it by saying that this book that we're discussing now was something that came from open-endedness research. And in fact, some of the insights, which I'll illustrate through talking about the butterfly, apply actually beyond AI or machine learning, which is why we wrote the book actually, because we thought that the points that we had surfaced, which have to do with how innovation actually happens, are actually important for society at large. And we wanted to make this point more broadly. So it does have a philosophical dimension. So one of the things we touch on, as you just alluded to, is this pick breeder experiment, which is where actually these insights came from. We created this website really to be able to study open-endedness, where people could breed pictures. And so it's very simple, really. Like the idea is like you'd see some pictures on your screen. Some of them might actually be from people who had bred them in the past. And so you're seeing basically what your predecessors had bred. But you would be allowed to then choose one that you like, and it would have children or offspring. And so you'd get baby pictures that came from that picture. And then from those, you could choose your favorite ones, and they could have children and so forth. So in effect, you're like breeding pictures, what I call pick breeder, just the way you might breed horses or breed dogs or something like that. And so
I still didn't understand. I'm sorry. So
I'm sorry. Yeah.
When I breed two pictures, so I take this pixel over here and this pixel over here, and I take the average, basically what I'm doing?
Oh, I see. Yeah. To be a little more specific about it, don't worry about breeding two pictures, actually. So for a moment, just imagine completely asexual evolution. So it's just because we don't need to have two parents to have a child in this world, because this is not the natural world. So just imagine an asexual world. So you can have a child, you don't need a mate. And so it's just a matter of mutation. And you just think intuitively, like if you had a child just on your own, it'd look kind of like you, but it'd be a little different because there's some mutation happens at every generation. And it's effectively what happens in the system in pick breeder. Actually, pick breeder does have a mechanism for mating that you can do within a generation, but it's not really important to the main point that most of it was asexual. Like most of it didn't involve.
So again,
mating.
I'm sorry to interrupt, because I want people to understand. I take a picture and it's, I don't know, it's 250 by 250, okay? And by process of very gentle mutation, I take some of the pixels and I alter them. I change the color. This is basically what I'm doing.
Well, it's like that, except I would add the clarification that there's actually there is actually an artificial DNA underneath the hood. So it's not like it just randomly chooses some pixels and changes their color. That's not what's happening. There's actually like something like a genetic encoding underneath. So in other words, like for example, if you have a child, it won't have 3 legs and like 13 arms. That just can't happen. Because it's not actually random. It's like constrained by DNA.
Okay.
And DNA has established certain conventions. And that process, which we call indirect encoding, how DNA actually more like encodes the phenotype of the body, is pretty complicated. And one of the underlying research topics behind pick breeder was actually that we had invented an artificial encoding that has some of those properties. So like if you had an image of a butterfly, it's likely that the offspring would also be symmetric, for example, because the butterfly is generally supervened by like a symmetric convention. And so the mutations happen, but they're kind of sensible. You don't need to worry about it as a user to understand it. Users, it just makes sense. Like, you mutate something and the children look like it. But it's not just like random pixels being turned on and off or something like that.
Okay, very good. Very good example. The idea of 13 legs. Okay, now I can change, alter, breed, and somehow I will get to a butterfly. And this is by itself amazing, but what you said is even more amazing. In the process of getting to the butterfly, the ancestors weren't even similar to butterfly.
Yeah.
Not only that, the objective of a butterfly wasn't even present there. Yes. And this is just something that it's so counterintuitive that you said, what again? What? How?
Yeah. That's the mind-blowing thing that came out of this experiment. This is not something we knew in advance. It was a surprise. But we discovered after hundreds or maybe a couple thousand people had been breeding pictures for some time, for months or even years, when we looked back at all the things that had been discovered, and there was a lot of amazing discoveries, like there was something looks like a skull, something looks like a car, something looks like a butterfly, and so on, all kinds of things that look like stuff in the real world. And you have to remember, this started from random blobs. So it's not at all obvious that through random mutation, you're going to get all these like meaningful objects, but you did. And so we were looking at what were the steps that led people to make these discoveries? And we discovered just what you said, which is that it would have been impossible for them to make the discoveries if they had been their objective. In other words, you can't find things by looking for them. So that's like really profound and really counterintuitive, because like almost everything we do in life, in our society, every institution that we have in our civilization pretty much sets objectives and tries to go towards them. Like that's the standard way to make progress, to create things. But what we saw in Pick Breeder was the exact opposite. You can never actually achieve anything that way. The only way you can achieve something is by not looking for it. And so that's really counterintuitive. And so people think when they hear that, how could that be? Why is that? Why would that be? And how do you know? Yeah, go ahead.
Now, I want, with your permission, just to weigh in and say that this is a very old problem proposed by Plato, the idea, or Socrates. The idea is that how can I search for something if I don't know what I'm searching for? So if I know what I'm searching for, I already found it. But if I don't know, even if I did find it, I wouldn't recognize it. So the idea of that, how can you search for something that you don't know, is a very old problem in philosophy. But what you said, I think it's a whole new level of, it is truly amazing. So so if objective is not the case, what should I strive to find? Novelty?
Yeah.
Creatively? Right. Just fun? Yeah. What is the objective?
Yeah. So that's an important question that comes, originates directly from what I just said. It's like, well, how do you actually find anything if you can't search for it? But to answer that question, it's important to understand why you can't search directly for something as an objective. The reason is because of what's called deception. It's because the stepping stones that lead to the thing that you're hoping to discover don't resemble it at all. So the things that lead to a butterfly don't look like a butterfly. The things that lead to the car don't look like a car. So if you were looking for a butterfly explicitly as an objective from the beginning, if you just started out with random blobs, you would not choose the things you need to choose because they don't look like butterflies. You can only recognize the important stepping stones to a butterfly if you're not looking for a butterfly because they don't look like a butterfly. And so that leaves this paradox and this question that you asked, which is, well, then how does anybody find anything in a situation like that? And and I just want to make it clear that you can find things in a situation like that. That's what's so amazing about Pick Breeder, is that it's not like no one could find anything because it's crazy. It's actually people found hundreds of images that were really, really great. But they, in almost every single case, 99.99% of the cases, were discovered by people who along that chain, for almost the entire chain of discovery, were not looking for those things. So what were they looking for then? What were they looking for? Well, they were looking for things that were interesting to them at that moment in time. So they weren't thinking about where they were going. I would the way I would kind of frame it more is that they were thinking about where they had been. Because when you're thinking about what's interesting, you're comparing what's in front of you. You have this kind of menu of possibilities. Where can you go next in your life? In Pick Breeder, it's which image should I choose among this selection? And so you're facing this decision point. When you're making that decision, you're looking backwards at all the experience of your life and thinking within that context, what's actually interesting here that I'm looking at? It draws on all your experience in your life. And people recognize certain things as interesting, like, for example, symmetry. Symmetry is interesting. Other things are interesting, like the shape of a circle is interesting, like circular shapes. And there are, of course, innumerable things that are interesting that are abstract in nature. It's at a visual level of interestingness when you're talking about Pick Breeder. But that causes those types of discoveries to be locked in. So like if I found something like bilateral symmetry and I selected the image that was bilaterally symmetric, I've locked in the concept of bilateral symmetry in some sense. It's like the first discovery of bilateral symmetry in nature, which is like a flatworm, which is one of our ancestors actually many, many eons ago. That's like a fundamental discovery, but it has nothing to do with butterflies. I mean, you don't know what this is going to lead to because it's just a blob that has symmetry in it. And it was chosen for that reason, because that's just interesting, independently interesting in its own right. And so the decision-making is related to an understanding of interestingness within the stepping stone. In other words, it's the idea that this opens up a playground. Like if I look at this thing, I think of it as there are so many interesting patterns that I might see if I go down this route, even though I don't know what they are. And what I'm interested in is the playground, not the destination. Opening up a whole new playground, and everything is a new playground. You know, like once you find the butterfly, you're in a playground of butterflies. Now you can look at all kinds of different butterflies, different color patterns and different kinds of shapes and sizes. And so you're trying to find the best playgrounds to open up. And this is what good players do. Bad Pick Breeder players set an objective. And I'd say that's the majority of them, because most people have been taught in our culture to think in terms of objectives. And so the majority of people who come into the site have a very bad experience and get frustrated because they can't get what they want. And then they see all these images there and they're like, how did this happen? Like there's all these discoveries, but I can't do anything.
Just a second. I have so much to ask you. It's like the Midjourney prompt, if you have an objective in mind, most of the time you will be very disappointed. But if you just want to play with the system, you will find amazing things. Now, I have two words. I think that the discovery of a butterfly from your description can be characterized as either a fluke or, in a better word, serendipity. The idea of accidental good discovery. But which leads, I think, you as a machine learning engineer usually are obsessed with efficiency, how to make the system more efficient and how to decrease the training time, etc., etc. This is what we do as machine learning scientists or engineers. And basically what you're telling me right now, don't go in the efficiency road. It's a bad road to go. We don't want the efficiency, because if I want, to make the process more efficient, I will not create something that is truly new and remarkable and creative. Would you agree?
Yeah, I mean, I would basically agree with that. I mean, I might slightly change the wording to say that the thing really to avoid is optimization. Efficiency is sort of a byproduct of optimization. It's like we want to optimize efficiently. But the fundamental mistake is to focus every single thing we do on an optimization type of framework. It's like I know where I'm trying to go and I'm going to optimize towards it. I mean, that's basically like the ubiquitous form of progress in our culture. And then, of course, we try to be efficient, and that's why we have metrics. So I agree that efficiency is like a big part of this. Like we invent metrics because we want to know if we're moving towards the objective. And if we're not moving efficiently enough, usually we would give up. Because, if it's like if you're working at a company and your boss says, your manager says, like, here's your objective and you show me your progress and it's not going fast enough, well, then the project's over. Like we have to do something else. Like it's a failure. That's efficiency. That's metrics. That's assessment. And that's all about objectives. And yeah, what I'm saying is that that's all a huge mistake if what we want to do is discover, innovate, and create. It's true that I should like at least put the caveat that, it's not always bad to have an objective. Like if your goals are modest, it can work. What I'm talking about are blue sky discovery types of things where there are many things that we don't know how to do at all. Those are bad to set as objectives because that will prevent you from achieving those things or discovering anything else because you're going to go straight down a deceptive path to a dead end and you'll ignore all the other stepping stones that are in the room that could have been actually useful paths to discovery, even if it might have been discovering something else. So yeah, it's and this is sort of segued into the point that this is actually a point about all discovery processes. Like this is the leap that's really interesting. This is what the book tries to do, to say PickBreeder is a microcosm for all innovation. You know, like some people will look at PickBreeder, see this lesson, and try to reassure themselves by saying, it's just PickBreeder. It's just some weird system. It has some weird properties. But my life doesn't work that way. Like I set objectives. I'm proud of myself and my objectives. But the bad news that I want to convey and why we wrote the book is that it does apply to you in your life. There's nothing different about PickBreeder at all. It's just the structure of all complex systems. You know, think about it. What does it mean to be a hard problem? It basically means I don't know what the stepping stones are to get there, to get to the solution. I mean, if I knew the stepping stones to get to the solution, well, then I would just solve it. So it wouldn't be a hard problem. And so if I don't know what the stepping stones are, obviously they don't resemble the solution because that's what makes it hard. And so the entire space of all interesting things is structured just like PickBreeder. So the lessons actually apply to every ambitious thing you might want to do.
Let me phrase it differently. If GPT-5 is an objective for OpenAI, it will be much less mesmerizing rather than just, you know, doing the novelty journey.
That is an interesting, and it's a very specific application of this point, and it's an interesting application of the point. So there's one nuance to what I'm saying that I think is important, which is that as you're going down these, what I would call gradients of interestingness, like you're following stepping stones simply for the fact they're interesting. Once you get within the valence of something that's desirable, like in other words, it's close. The way I would put it is one stepping stone away. Like once you're one stepping stone away, like, in other words, you know you could get there. Like there was a point, I actually was the one on PickBreeder who found the car. Actually, finding the car was what caused me to realize all these things because it was such a weird experience because I wasn't looking for cars. So it's like it really blew my mind when I found this car. But there was a moment that was like a couple steps before I found the car where I realized I could get a car. At that moment, when you're like a stepping stone away, then it does make sense to double down. Because you know where you're going at that point. Then you're like, oh, I'm getting a car. I can do this. So the question, like when you interpret something like OpenAI is it one of those situations? Like, is it like, well, we're just one stepping stone away from this amazing thing, GPT-5. So we should just double down and just head down that path. We already know what it is. Or is it a situation where actually it's still really far away? And so we don't really know what the path is to go there. Then it would actually be more in our interest just to think more in terms of what would be interesting. Yeah.
How do you decide? How do you decide? How do you decide if you are one stepping stone? Because, you know, with all due respect, I think that the car example, although very vividly enlightening, is a very simple example.
Yeah.
Okay. So it's very easy or relatively easy to say, okay, I can go in that direction and create a car. But it's in our life. And again, you want to take the wisdom from the idea of PickBreeder to our life. And it seems, you know, that the transition might be a little bit more challenging.
Yeah, no, I agree. I mean, I think that the question of when you make the transition, like when you go switch from an interestingness search to just like an optimization, is like the fundamental question of all visionaries. Like to me, that is what it means to be a visionary, is to know when to make that switch. You know, a lot of people think the word visionary, like you think about this word, is a description of a person who sees many stepping stones into the future. Like they're telling you, you know, like this is the way the world is going to be 15 years from now, and I'm going to steer the ship and get us there. I believe that is totally false. I don't think that exists. Like that is just a fable. What I think is a visionary is the person who understands the inflection point where something has snapped into possibility because of stepping stones we've traversed non-objectively. So it's like things have been happening in the world, new things have been created. Suddenly something else becomes possible because these new stepping stones are in the world. The visionary is the first person to realize it. And like an example of that is something like Steve Jobs, who like he can see that like an iPod leads to an iPhone. It's not an obvious, that's actually the next step on the road. Like I would think that iPod leads to like even better music players. I mean, it looks like it's on a gradient of increasingly good music players. You've got like audio, you've got like record tables, and you've got audio cassettes, and then Walkman, and then you have an iPod. What's next is some kind of audio player. Like nobody would think, oh, we're going to get a new phone out of this. But this is the inflection point. Like suddenly something else became possible on this meandering path. And he's the first to recognize it. And that's what visionary leadership is.
And again,
vision to see that.
And again, the iPod Touch was very similar to the iPhone 1. So, the distance that Steve Jobs had to go wasn't that large. Again, he was a visionary, no question about that. But iPod Touch and iPhone 1 are quite similar. Basically, they are the same. Just iPhone is just iPod. So before we move on to my last question about your new company, Maven, I want to make sure that I understand. The one of the reasons, or I think the most important reason that we got a car and butterfly and skull and all the things that we can relate in our daily life is that along the way, people have made decisions that preferred things that we see, like symmetry, shapes, etc. In other words, let's say that we play pig breeder in an alien planet, we would maybe we'd end up with things that in that alien planet. Would you agree?
Yes, certainly. I mean, pick breeder is like a mirror. I mean, it's reflecting our humanity back onto us. And you can really see that in, for example, that some users, like people were allowed to open accounts. And so you could store all the images that you bred in your account. And so we could see that some people had very different kinds of images than other people. Like there was a woman who had basically a bunch of bugs in her account. So she had like beetles and butterflies and ants and cockroaches and everything you could think of. It was all in one account. And so she said to me, is there something in Pick Breeder, that's like designed to help produce bugs? Because I have all these bugs in my account. And it's the fascinating thing is that the answer is no. Like it's completely inside her. She doesn't even know that about herself. Because these are like implicit instincts that we have, and my account didn't have all these bugs. It's just something she's got instincts about the geometry and symmetries that like relate to bugs. And my account actually was full of faces. So apparently I like faces, I guess. That's something. So like, yeah, it's just totally a reflection of the kinds of things that we resonate with.
Wow. It's the ultimate Rorschach test. Okay, let's move on to my last question. You nowadays you are the CEO of a company called Maven. Maven is an English word, comes from Yiddish. It's or Hebrew, the word mevin, which means understand, and which is a very smart person. And maybe Maven will correct all the bad things with social media. So could you please tell me how did you get to the name Maven? And what Maven, I'm afraid to ask what is the objective of Maven because we talked about objective being one. But I can't. Please tell me what is the objective of Maven.
Okay. So actually, thanks for that lesson on the origin. I didn't know that. That's very interesting. So it's in line actually with why we chose the name. We were actually thinking about it as there's a kind of person, I call it an archetype of person that many of us know, who's like the kind of person you go to when you want someone to make connections for you. So, it's like, I'm working on this project and you tell this person, and they say something like, oh, you should talk to that guy and you should talk to that woman and you should read this book and go to that website. And like, I know everybody you should talk to and this investor and that website. that kind of person, we were like, what is the name? What is the word for that? Because we wanted to name our site after that word. Like we wanted to name the service Maven after that word. And the closest word we could think of was a maven. There's not really a word for that, but we're like, that's sort of like a maven, like a person who connects you to all the right things. So we named it after that, which relates also to I guess the original Yiddish origin as well, which I didn't know.
One of the greatest magicians, American magicians, which died recently, called Max Maven. I don't know if you're familiar with the name, Max Maven. And again, he chose his name by just Maven. Okay, so what is the objective? What do you try to do?
Yeah, so the reason that there is this Maven service goes back to the book, which goes back to PickBreeder. And PickBreeder was the inspiration for the book. And PickBreeder also inspired a number of new algorithms that were based on these open-ended principles. They're like the novelty search algorithm is one. There's a whole set of algorithms called quality diversity algorithms that grew out of this. So a bunch of algorithmic insights grew out of it. And so what does that have to do with Maven, the service? Well, what it has to do with it is that this book caused me to live a parallel life. This is a really weird story because if you think about it, the book is more like social critique than about really AI. It does, obviously, it refers to AI research, but it uses it to motivate social critique because it's basically saying in our culture, in our society, and this applies worldwide, it's not just one country, basically worldwide, like we run everything through objectives. All our institutions are objectively driven. Like if you ask for money to do research, just as one of millions of examples, they want to know what your objective is. Like that makes absolutely no sense in light of the insights in the book. There's an objective paradox. That's what I like to call it. This paradox that actually setting an objective prevents you from reaching it. So why these research institutions running by setting objectives? But if you have a research lab,
did you send your book to the NSF?
No, but that would be that was one place I still would love to discuss the book with. Yeah, totally agree.
I don't need objective. Just give me money.
Yeah, well, I mean, the real argument is I should be able to just tell you why it's interesting without illustrating an objective. I mean, it's not that we can't discuss these things because that wouldn't be an acceptable proposition. I mean, you can't just say, just give me money because I'm me. But you should be able to motivate why your subject is interesting. In other words, how am I opening up a new playground where there's almost certainly going to be some kind of discovery, even though I can't tell you what it is yet? That's the kind of thing that I'm advocating for. And so this is not just about research. Like educational systems are completely objective. You know, schools are evaluated based on raising grades. That's wrong because like there's a deceptive gradient towards everybody getting an A or 100% in their class. Like you can't get all the students in the country to get a 100% simply by raising grades on a linear gradient that just goes up. And so look, it applies to the government and how it evaluates and runs things. It applies to education, it applies to professional worlds where everything is objectively driven. Even your personal life, it applies to. Like, I mean, when you go to a dating service, they want to know your objective. Like, it basically you have to write in, like, you know, I like blonde hair. I want somebody with this level of education, blah, blah, blah. How do you even know what's going to make you happy? It's the same objective paradox. Again, it's just it appears over and over and over again. It's always deceptive. Like you follow that gradient or you want to make a lot of money. Is your goal to make $1 billion? Well, guess what? Like getting a job that makes more money won't help you. It may look like you're going up, but it won't get you to $1 billion because that is just too ambitious and it's too deceptive. And so like everything is like this. And I felt that this issue needs to be communicated and discussed like society-wide because nobody cares at all about this. Like there's no discussion. It's not like there's an anti-objective movement on the streets with protesters. Nobody even cares. So I just thought like this, I just have to do something. And with my co-author, Joe Lehman, we decided we should write this book. And so after we wrote the book, the interesting thing that happened to me is that this is what most people don't know. I became the focal point for this issue. And that what the issue really boils down to is serendipity. Like most people in our society, which is basically the whole world, feel as if they do not have sufficient opportunity to explore serendipitously in their lives. This means in the professional context, educational context, personal context, it's like you can't get permission to do things you really want to do. It's like, I think this would be so interesting, but they'll never let me do this. They'll never let me do this work. They'll never give me funding to do this in my research career. Like it does, whatever the context is, people feel restricted and straitjacketed all over the place. And I know this in a way that no one else knows because I became the focal point for people complaining about this because of the book. People would come to me because of the book and tell me about this at a personal level. And I spoke to people from all walks of life. I talked to artists, medical doctors, retirement planners, military planners, high school students. I just talked to everybody about this, people who run huge billion-dollar labs. And I learned, that this is a huge issue. After years and years of hearing people talking to people about this, and it's really weird because I'm an AI researcher. I'm not a social scientist. I'm not a social critic.
You're not a psychologist.
Intellectual. It's like, yeah, I'm not a psychologist. I mean, and some of these sessions were like therapy, really. I mean, people are on the verge of tears sometimes talking about these issues because a lot of people are like, I can't explain to people why I'm doing what I'm doing, like my parents. I can't justify it to my parents, and it makes me feel horrible. And so when they read the book, they're like, oh, finally, there's actually a justification. Like, why am I doing the things? It's because I'm following the path of the interesting. And so to me, though, me personally, not those people, but me as the kind of focal point, it started to accumulate in me. Like it started to really emotionally grab me, all this issue that people have, which is so outside of AI, which is my real field. And I eventually, after like 7 years, just felt like I have to do something about this. Like, I can't just talk about it anymore. Like, there's got to be something I could actually do to change things. And I didn't want to just be a business consultant. But then it occurred to me that, you know what? These issues, that the ideas in the book, the idea of non-objective searches, of increasing serendipity not being a random accident, but something you can make more probable, they originate in algorithms. Like, the book originates in AI research. Not in philosophy. It's not a social critique. Ultimately, it was a book about how research shows something empirically to be the case. And so that made me think that I should be able to build a system that works the way that open-ended algorithms work, because that's what I spent my whole life thinking about, is open-ended algorithms, but where I could put people inside of that, and then it would work the way things should work. Sounds very ambitious, but I started thinking that might be possible. And then obviously it's not I can't re-engineer society, so that's not going to happen. But then the next option is, but on the internet, you can engineer things. Like, you can make a network that works however you want. And so I thought, oh, you can have a serendipity network. It's actually possible, like, to put people inside this context that works the way that open-ended algorithms work and makes the world more serendipitous. And then, of course, the next thing that occurred to me was, well, wait a second, if there's people in a network online and there's information going back and forth, that's basically a social network of some sort. It's just a new kind of social network. And then it occurred to me that that's actually a good thing, because all these social networks have all these bad unintended consequences, which then it occurred to me was, actually, the reason that the social networks have all these bad unintended consequences is the objective paradox. Like, the idea of maximizing likes and maximizing follows to maximize attention is a very objective notion, and is just another instance of this overall ubiquitous assumption that everything should be objectively optimized in our lives. And so that made me really excited. I was like, well, actually, this is like a really timely counterpoint to the way that we've been running the internet, and would offer an alternative. And so that became Maven. That's where it's the serendipity network that I envisioned there. And we've been working on it for a year, and it exists now. So you can actually go to the App Store. You can go to the Android store. You can find us online. You can download it and install it. HeyMaven.com is where it is.
The idea is to connect ideas.
It's built.
Yes, the idea is to connect ideas rather than people. So can you please, when I install the Maven app, what am I looking for? For a topic that I'm interested in, and then Maven will find other things or other people that are interested in the same topic, or let me put it differently. What is the best way, in your opinion, to utilize what Maven has to offer?
Yeah. So what we say about Maven, kind of to put it in a nutshell, is that on Maven, you follow interests instead of following influencers. So we take away the popularity contest, which is very objective. So everything else in social media is a popularity contest, which is a maximization, optimization type of a process. We completely took that away. So here you just follow pure curiosity. So you tell it what your interests are, and we'll automatically then start to expose things to you that are correlated to your interests. That's what you'll see in your feed. If you submit content to Maven, so if you're actually one of the producers rather than just the consumers, if you submit something into the system, it will figure out the interests that would be associated with it automatically. So it's not like you're going to like a forum like Reddit or something and just like you have to go to the right subreddit and you share it with the right people. On Maven, it just figures out who should see it. And that's interesting because it's cross-pollinating, because it's basically saying, oh, this might be interesting to people who are interested in architecture, but it also might be interesting to people who are interested in Israel or something like that. It could be interesting to two groups at once, like architecture in Israel. So
And
it'll go
here
to both
comes the
groups. You don't have to
serendipity.
worry about it. And here comes the serendipity. Yeah, because you're going to be meeting people who aren't just the popular people of the day, who aren't just like the worldwide consensus of the piece of media that's like most sensational for the day. You know, there's a lot of convergence in social media because it's so objective. Like the people who have the most followers dominate the conversation every single day. Of course, those people are interesting. Most of them are interesting. But the thing is that it gets redundant and it causes us to miss out on 99.9% of humanity who actually also sometimes have interesting thoughts in their head. And so this will actually expose you to all of that churning humanity, which is underneath the 0.1% who have 100,000 followers, and their ideas and their thoughts, and allow you to actually get interaction. Because like with people who are at that high level, you generally can't have a real conversation with them anyway, even though they dominate the conversation. And so you get real interaction, real connections between people based on ideas.
Now, I have seen the movie The Social Dilemma or The Social Network, and I know why it's bad, but I also understand what is the business model. What is your business model? If it's not about maximizing time and maximizing attention, etc., and maximizing like and clicks and etc.
Yeah, yeah. We'll have to acknowledge that we're taking a risk because we got rid of the main mechanisms that people have been using to get people addicted to make the money that they make. I mean, obviously, it's the likes and the follows that are keeping everybody around. And we've just actually gotten rid of them. So this is pretty radical. And we think, and we're hoping, and this is basically a social experiment, that the alternative, which is rather exotic right now, but perhaps it shouldn't be exotic, is appealing. And that's why it's going to be a viable model, because people are just, many people, maybe not everybody, are sick of all the unintended consequences of that model, which is, you know, like the fact that if you're in an eternal popularity contest, then that's why you have the disinformation and the echo chambers and the personal branding and the narcissism amplification and on and on and on, like all these bad things. And so you come to our site and the incentives have completely been pulled out from under all of that stuff. So that stuff is gone. And so that is a reason to be there, is because you will feel completely different. You won't feel anxious and nervous, and you won't feel like you just ate like poison for breakfast after you like, you know, go through that doom scrolling. It's a completely different experience. But to maybe put one more concrete practical reason, you don't need followers. You know, we are living in this, it's a tyrannical situation where like the only people who get a chance to have actual engagement are this like tiny slice of humanity who have like 10,000 followers or more. And that is like 99, that's like 0.1%. So like this huge slice of humanity is not being served if they actually want to get engagement and interaction from actual other people. You can do that on our site. You actually can meet people and talk to them, and they'll actually talk to you, even if you don't have 10,000 followers, because we don't have followers on our site. It's only based on matching interests. And so that's hopefully enough, even though we have taken away your addictive mechanisms. But, you know, arguably for a lot of people, that's a good thing, is to get a little of detox.
I didn't understand. If you don't get paid by the users, and I think, and I assume that you don't get paid by the users, again, what is your business model?
Oh, okay, I see. Well, I was trying to answer it as this is why people will still want to come. But yeah, the
Okay,
next question is, well,
no.
how do we?
For
Yeah,
you, why you will still want to do it in 6 months
how we
from
make
now?
money? Yeah, yeah,
Yes.
yeah. How will we actually still make money? Yeah, obviously we need to support ourselves. And so the answer is that if we attract sufficient interest, if we can demonstrate that people actually want this, which is the question, then that would just mean that there's enough people who want this, that there would be an opportunity for some kind of revenue. And so what kind of revenue? Well, we can, so we haven't made this decision in some final way. So I don't want to promise something here, but we know that, like, for example, people are telling us their interests. That's like how the system works. People are following interests as they encounter new interests. Actually, the system constantly surfaces new interests. So you can follow those too. That's serendipitous. but so we know what people are interested in, so we can easily then show them things
And
that
sell
might
information. Okay,
actually
okay.
be products that are aligned with their interests. And the nice thing about it is that we don't need to scrape your web searches. We don't need to like figure out who you are because like you already told us what you're interested in. So we don't need to have this kind of invasive approach to advertising, and we can just try to show you things that are aligned with those interests. So that's I'd say it's a likely thing that we use that because it hasn't yet been demonstrated that you can support a social network without advertising. Um, but there are other possibilities too. I mean, there are also subscription models, and there are also like the possibility of having other types of services associated with the system that supports the system, while the system itself wouldn't be advertising based. So we haven't made a final decision on this, but with sufficient interest, I think there'll be lots of options and opportunities.
Listen, the minute I'm finished the conversation with you, I'm going to download Maven and play with it. And
Okay.
you know,
Okay.
since many of my viewers haven't heard the word serendipity, I think until now, I want to give a very nice example that Malcolm Gladwell, you know, the best selling author said. He said that the idea of serendipity, or he utilized the idea of serendipity by going to public libraries. And when he searched for a book in a public library, serendipity will show him, you know, books to the left and books to the right, which is basically on the same subject, but it's not. It's a very broad thing, okay? And more often than not, just by picking one book and just go over all the books in the vicinity of this book, he will find things that he would have never found. Okay. And this is basically what you're doing at Maven. Okay. This is one
Mm.
area of interest, and this is another area of interest. Or I can use data science to say, if you're interested in this, you might be also interested in this. And the combination can be serendipity. Wow, I didn't know that I can combine or see the thing. So again, go to public libraries. Ken, it was mind blowing. I think, you know, what you said about your AI book, you know, why, just a second, why greatness cannot be planned is such a profoundly different AI book from all the other AI books that I've read, because again, it's about social critique. And it's not about AI, it's about our life, and it's about our goals, and it's about how should we live our life, even though the word should is a very problematic word because it implies ambition, objective. And the idea that it stems from the AI research makes, I think, it even more reliable. So I recommend to you all, please go and just read the book. It is very, very interesting. So first, thank you for your time. If I want, or if my viewers in the machine learning community wants more of your work, what's your, uh, what's your suggestion? Should they start with your neat algorithm paper, or what would you recommend for them to do in order, you know, to start playing around? Let's say that, you know, they know TensorFlow and they know PyTorch and they deal with CNN and transformers and wave to vec, and they want, you know, to open up to open-endedness algorithms. How can they do it?
Yeah. So let's see. So tutorial on my own work. So basically, I would you could start with NEAT. I mean, that's where my career started. So a lot of people would start learning about me with NEAT, the paper on NEAT, Evolving Neural Networks Through Augmenting Topologies. It's a very well-known paper. This is easy to find. And then I might go to the novelty search algorithm. It's Abandoning Objectives Evolution Through the Search for Novelty Alone, which is a description of some of the research that underlies the book. And then I might look at some videos. There's videos online. I gave a talk at TTI Vanguard about Why Greatness Cannot Be Planned, which is probably the most popular talk online. You can find that one, or you can find where I did an interview on a machine learning street talk show, which is also about the book, which is also like has a lot of views. So those are like quick ways to learn about the stuff I did, and maybe to jump forward in time to more recent things that you probably want to look at the POET algorithm, POET, paired open-ended trailblazer. This is more recent work that builds on all that stuff. It's more kind of aligned with modern machine learning stuff. And maybe even the most recent thing was evolution through large models, which was done at OpenAI. It's the last publication I did at OpenAI, and the only publication I did at OpenAI actually, but summarizes a lot of work there, and sort of brings some of these ideas, including these open-ended ideas, into the world of large models and language models, for example.
So again, even if your job, even if your research deals with LLM and, fine-tuning LLM, like, I don't know, LangChain or whatever, you can still use some of Ken's idea into your work. So this is basically what you did at OpenAI. You use those ideas in the context of LLM.
Yeah, for sure. That's a good point. I just want to highlight that because, yeah, I mean, some people might be like, oh, evolution. What does this have to do with anything I do? I do models. But the thing is actually that the concepts that were discovered in the context of evolutionary types of algorithms apply much more broadly. Like when we talk about non-objective searches, it doesn't have to be evolutionary. When we talk about open-ended systems, they don't have to be evolutionary. And so, this is something that OpenAI recognized. And partly why they had me lead the open-endedness team at OpenAI, is that like these concepts, these open-endedness concepts, some of the fields that emerged, subfields that emerged from open-endedness, are very relevant to what we want these models to be able to do, which is ultimately we want these models themselves to be open-ended. Like we want like a GPT that would actually have interesting ideas and follow down rabbit holes of interestingness, which I would say currently they don't do. And so they're certainly relevant to the present day and not just of historical interest.
Okay, so you have a lot of homework to do, guys. Thank you so much, Kנת Stanley, for what you contributed to humanity. It's much more important, profound, and relevant than multiplying 2 5-digit numbers on your head. Thank you so much.
Thank you. Thank you. It's been a pleasure. That was great.